The first of two lectures on design patterns. This week we're going to look at some ways in which we can organize the code, and next lecture we'll look at some design patterns for organizing the way in which we interact with the data. First of all, a little introduction to what we mean by design patterns. Design patterns really describe general solutions to general problems. And I describe it like that because there are problems that can occur in all kinds of different settings. So we might need to sort through some data, and that might be in a filing cabinet, or it might be in a database, or some other way, and some other location, some other context. We might need to iterate through a data collection that perhaps has got an unknown structure. Or we might need some mechanism whereby an object-oriented application can interact with a relational database without necessarily having to bury all the relational database commands, the SQL, inside the object-oriented code. Now there are all kinds, lots and lots of general problems. And so a design pattern is a solution to a specific problem, although the problem is described in general terms. And what we can do is take the design pattern, having identified that the problem we're looking at in the real world is some kind of variation of the general problem. We can take the design pattern that fits that general problem, take its solution, and then adapt it so that it fits our specific real world problem. And that should help us to do a few things. First of all, it will help us by giving a name to the pattern. I'll come back to why that can be helpful a bit later. It can help us in understanding a little better the problem that this pattern addresses, because the pattern will have a description of the problem in general terms. The pattern will also have a general solution for the general problem, and there might be some consequences, some side effects of using that solution. Those will typically be elucidated in the description. Now, of course, being a general description, we've got to take the pattern and customize it to satisfy the specific requirements of the specific instance that we're dealing with of the general problem. So it's not just a case of, oh, I'll use pattern X. It won't work that way. We have to tailor it to our specific needs. Why bother doing this? Well, a couple of things. First of all, these design patterns haven't just come out of some person's mind because they think it's a good idea. These are actually tried and tested techniques that have been used in an industrial setting in many kinds of areas, and therefore they are trustworthy. We can use them confident that they will provide a good solution. Not only that, but because they are successful, and that's why they've been published as a design pattern, these designs are successful in solving the problem, but they're also well structured, which means that our designs become easier to define and to follow. And therefore, of course, the knock-on effect of that is that the code will be easier to write, easier to maintain as well, and to debug. Another thing that can happen sometimes is that a design pattern will highlight some good alternatives, because sometimes you might have a particular problem, but there might be 2 or 3 different patterns that could be used to solve the problem. And therefore you might get some comparison between the design patterns. If you're using a design pattern, then the chances are you're going to improve your system documentation and certainly improve the maintenance. Because if a designer is familiar with that pattern, that designer will immediately be able to follow the design. Because knowing that it's a command pattern will mean that the designer is able to look out for a certain structure. So, for example, designer A uses the command pattern, for example, and then leaves the company. 6 months later, 12 years later, whatever it might be, the documentation is still available. Designer B comes along having to do a bit of maintenance or enhancement, and there's a note in there to say, this application uses the command pattern. Designer B immediately knows what the command pattern is, and therefore has instantly some correct expectations of what to find in the design and in the code. And so what we'll find then is that design patterns become a lexicon, a vocabulary for design, and this aids communication. Not only does it aid communication between one designer and the next who are separated by time, but also for designers who are working together on the same project. They can talk about the command pattern or the template pattern or whatever, and so long as both are conversant with what these patterns are, then it's a very good abstraction for talking knowledgeably and informatively about a design. Now, a framework, and we've been using a framework since we've started work on this module, a framework usually incorporates design patterns. For example, if we were to use the Java Graphics API to develop a graphical user interface, if we're writing that kind of an application, then we'll find that design patterns are littered all over the place. You can hardly look at a class in the standard Java environment without finding a pattern of some sort. An observer pattern, a composite pattern, an iterator, and so on. Lots and lots and lots of patterns. Now, our internet applications have been using a subset of the Java Enterprise Edition API. This uses design patterns as well. The framework sometimes will impose a design pattern upon our applications, and other times we are free to adopt patterns that we want to make use of.